So when you look at what has to be designed, the car, from the side view, I have to come up with the shape of this curve. So I could take this shape, that shape. I could take different shapes, some constraints, as an engine and whatever, so that the drag, the wind drag is minimized. Okay? So is that a practical problem? Is this a practical problem? Do you think we try to solve it and use it every day? Different models come in cars, in planes, in boats, in everything. Okay, so now when we get an answer here, which one is the best one, you get a value of x. How many numbers do you get? When you solve an optimization problem like this, when you get an answer, to specify the answer, how many numbers do you have to give?
2.
Because the domain is two-dimensional. When you pick the curve, and you tell somebody, you know, I've done it, now I need so much money, because I've solved your problem, how many points do you have to specify? Say it loud and proud. You've been answering everything correctly. Infinitely many. And by the way, which infinite? Countable. This is uncountable. It's a line. You can map it to an interval. This is your R. Anyway, so we are doing optimization in how many dimensions? How many dimensions? Louder. You think infinity is something, you know, a philosopher who looks at a tree and sits there? Or is this for us engineers? Every time you design something which is a function of time, interest rate, what it should be or whatever, as a function of time, how much fuel cost, it changes at every time. It's a function of time. So when you have to pick something which is a function of time, the optimization is done in how many dimensions? How many? The answer is a function curve. So which dimension is a domain when you're choosing the best one? How many dimensions? Does everybody see it? I hear silence. So we do optimization, we solve actual real problems, engineering problems in infinite dimensions. So not just the size of a set. And when I say infinite dimensions, which kind of infinity? And then if I have to get answers, what am I going to use? Are these engineering questions? What do you think? Are they engineering questions to you? Of course. And this is still smooth things. But in real engineering, you don't even get that most of the time. You have discrete things to make decisions on. You know, if you're a very engineer who designs shirts, you'll say, okay, what color should it be? Color? Is color a number? No, it's a discrete thing. I have to optimize that. I have to optimize how many buttons where. Look how many different types of decisions I'm making to get the best one. What kind of optimization in which domain is it? What do you need for that?